Hey, what's up guys? My name is Saurav and this is my YouTube channel Data Science Novice. So if you are new to my YouTube channel, please do like and subscribe. Your efforts are massively appreciated. So in the last video, we talked about transfer learning where we use the learning of one model to train another model. So in this video, we are going to learn another type of network that is recurrent neural network. I have already written a blog post about it, so I'm going to use that blog for this video. So let's jump to the blog post. So here I am in the blog post. So why do we need RNNs? Although ANNs and CNNs can do most of the work, but there are some areas where we need much more than feature extraction. So far our neural networks are able to understand all sorts of pattern, but we need more than that for some specific problems. So what we need one thing that RNNs are capable of, that is memory. Able to understand past event and make useful relationship with present information, and RNNs are good at it. They are used for sequence of data like time series forecasting, albeit stock price prediction, text generation, speech recognition, etc. etc. Let's take an example where we use RNNs. When we ask Google Assistant that who is Tom Cruise and where does he lives, the assistant will tell you that he is an American actor and lives in Beverly Hills. You must be wondering what is great in that. Well, machine does not understand contextual meaning of word. So when I said where he lived, how does assistant knows that we are talking about Tom Cruise? So here the RNNs made a connection between Tom Cruise and the pronoun he. It learned when we are using he, we are talking about Tom Cruise. This is a very simplified example of RNNs and they are capable of doing much more complex things. So what is RNNs? First, we need to understand the representation of RNNs because if you are beginner, you may end up getting confused with the representation. So here is the graphical representation of RNNs. Here we have one input node, three hidden nodes, and finally we have one output node. Initially, this might look similar to artificial neural network, but on a closer look, we find that in three hidden nodes, the output of these nodes are fed back to itself. So on compressing this whole thing, we get this right hand side diagram. And this is the standard representation of RNNs and you can find it anywhere. So from the diagram, we can say that it is a type of neural network where output of the previous state is fed as an input along with data to the present state. And this property of RNNs give them the power to remember past information. This might seem confusing, so to understand it better, we unroll this network. So we can represent it like this. So at each timestamp, we are getting some input and outputting something. And the same output is fed back to the network. So to make things easier, we ultimately represent the network like this one on the right hand side. So let's understand this network by doing an activity where I will give you five numbers and you have to add them and give me the answer. So here are the five numbers: 1, 5, 9, 10 and 12. So I'm guessing you have answered it correctly and the answer is 37. Don't worry if you didn't get it right. I'm not here to test your skill. It's just an activity to make sure you understand RNNs. So when I give you the number, I'm giving you data at different timestamp. And according to that, you are processing the information and finally giving me the 37 as an answer. So why were you able to do that? This was possible because of two things. First, your mathematical ability to add numbers. Second is the ability to have a short-term memory so that you are able to remember those numbers till the time task is completed. Now on the right hand side, same thing is happening. At each timestamp, we are giving a number to RNNs and finally we get 37 as the answer. RNNs are functioning similar to our brain. They are capable of doing this because they are able to hold the information. And using that information, they are performing mathematical operations. In this case, addition of five numbers. I guess this example should make things clear for you. Once we have the intuition on how RNNs work, things get easy mathematically. Next, we have mechanism of recurrent neural network, that how it works and what is the mathematics behind it. RNNs have recurrent core cells, also known as hidden state. Every time new data is fed, these hidden states gets updated. So on the right hand side, we have equation for that. So let's understand this equation first. So here we get hidden state from previous timestamp, that is ht minus 1. Next we multiply it by some kind of weights matrix, that is WHH. Next, we have input coming at timestamp t. It is also getting multiplied by weight matrix, and then we have our bias terms. After adding all these inputs, we squash the values by using tanh function, which finally gives us hidden state at timestamp t. Now we can output the information at timestamp t by multiplying it with weight matrix, and we pass the same information to next hidden state. And if you look at the diagram, same thing is happening. We get input from two different sources, namely previous timestamp and data at present timestamp. Then we squash it using tanh and passing it to the next hidden state, and also outputs it using some kind of weights. So here you see that with the help of ht minus 1, that is hidden state at time t minus 1, we are making sure that we take care of previous information. And with the help of xt, that is present data, we are making sure of present information. And by combining them, we are creating a relationship between past and present information. And this whole process is repeated across the network. So this is a layman explanation to a more complex process. Note that my aim is to make you understand the intuition behind all these things happening. So once you have the idea, you can deep dive into the theoretical part. Next, I would like to talk about the variation or types of recurrent neural networks. So depending upon the type of problems we are dealing with, we have different variation of recurrent neural network. So first we have one-to-one network, which is simplest of all network. So here for each input, we have an output. For example, stock price prediction or image classification problems, where you give the image to the network and it has to classify that whether it belongs to a particular class or not. And if you are wondering that can we use RNNs for image classification, then yes, we can use them for image classification. Next, we have one-to-many type of network. So here, for each input, we have multiple outputs. For example, image captioning, where we give network an image and it has to describe the whole image. So for example, if we give an image containing dog that is jumping, then the network will describe it that there is a black or white dog depending upon its color, and it is jumping, lying, or whatever activity the dog is doing. So you see, we only give the image and we got multiple string as an output. And in upcoming videos, we will be doing project related to image captioning. Next, we have many-to-many type of network, where for a sequence of data, we are getting another sequence of data as an output. And the best example could be chatbots, where we ask a question which contains multiple words and it give answer as an output in a multiple words. Lastly, I would like to talk about many-to-one type of network. So in this case, we give multiple inputs and get a single output. This type of network is used in sentiment analysis. So for example, movie review. So given a movie review, we have to design a network that will tell us whether it's a positive or negative. So these are some of the variation of recurrent neural network. Next, let's understand the training of recurrent neural network. So here we are taking the example of character level language modeling. So in this type of modeling, we try to predict the next character in the sequence. So I have taken the example of word fame. So the first thing we have to do is to convert the string into one hot encoded vector, because we know that algorithm does not understand the word or strings. We need to convert them into numerical format. So once this is done, we pass them to the input layer. Next, the weights are initialized for the hidden state, and I have written the formula to calculate the hidden state, and we have also talked about it. Then these hidden states are passed to the next state, and at the same time, we output them depending upon the type of network we are dealing with. And for final prediction, we pass the output to a softmax layer to get the probability. So once the network is trained, and if we type F, then it will predict A, then M, and then E, because we have trained it to be like this. Obviously, the process is way more complicated. I left back propagation part, but that is understandable if you have been following my video series. And we will talk about back propagation separately. Next, I would like to talk about back propagation. But before that, we need to understand one more thing, that is training in batches. And this is something we do more often in deep learning. We do not train the network on whole data. So why do we do that? There are two reasons for that. First, training on whole data set is computationally expensive. So when we say computationally expensive, that means the network require more powerful CPU or GPU for the training. And the second reason is it slows down the learning process. You may get greater accuracy, but it would end up taking a lot of time. And in deep learning, time is money. So to deal with this problem, we feed the data to network in many batches. So for example, suppose we have 20 data points. We can divide these data points into 4 different batches, each containing 5 data points. Then we feed first batch of data and accordingly network will adjust its weight or learn from the first batch of data. And we will have some losses as well. Next, it will use the weights of first batch as an initializer and train on the second batch. And this will keep on repeating till the time we want. So why do we do that? Because mini batch training require less memory. Since we train the network using fewer samples and the overall training procedure require less memory. That's really important if we are not able to fit the whole dataset in our machine memory. Another thing is a typical network train faster with many batches. That's because we have updated the network weights after each propagation. In our example, we have propagated 4 batches, and after each of them, we have updated our network's parameter or weights. If we used all the samples during propagation, we would make only one update for the network's parameter. So that's how batch training happen in most of the network. And again, this is a vast topic and I cannot cover everything. So I would suggest you to read more about it. Next, I would like to talk about back propagation. So once we have the data in batches, how do we make sure that we are learning from the data? And here comes the back propagation part. So in forward pass, data goes from input layer toward the output layer. And there we calculate the losses. Obviously, in first go, losses will be high. We won't be able to get good predictions because network has not learned anything. So to make the network understand or learn from the data, we pass these losses information backward. And according to that, the network will start adjusting the weight. And this is known as backpropagation, where the weights are adjusted in order to minimize the loss. For example, suppose network predicted image of a dog as a cat. The loss in this case will be high. Then the network will pass the information by traveling backward in the network and adjusting the weights accordingly. Next, if there is an image of dog and it is predicted as dog, then the loss will be less because our prediction is right. And again, network will pass the information by traveling backward. But this time weight won't be adjusted drastically like the one in the first case. The mathematic used for backpropagation is called chain rule that we learned in our calculus class. And the weights are updated using gradient descent or whatever algorithm we have used in the network. So here you see the black arrow represent the forward pass and the red arrow represent the backward pass or the back propagation. Not everything is great with RNNs. Due to the complexity of the network, we encounter two problems. One is exploding gradient, another is vanishing gradient. And I would be talking about vanishing gradient because that's more complicated and it requires different architecture to deal with the problem. So let's understand vanishing gradient by an activity. Suppose there are 100 people standing in a line like this chain in the picture, and I passed along information about me to the first person in the line. Then the first person passed the information to the next person, and so on and so forth. So, my question to you is that will the information at 100th person be same as I passed to the first person? And the answer is no. There will be some changes in my height, my weight, or any other information. And that is understandable because as the information will be traveling to one person to another, there will be a loss or modification of the information. This is what happens in RNNs. While backpropagating through the network, some weights change a little due to the small change in the gradient. And this small change keeps on getting smaller and smaller as it backpropagates in the network. And this cascading effect happen across the network, causing the network to train half of the network well and other half of the network not so well. And here is a motivational picture that you must have come across on LinkedIn or Instagram. This picture sums up the idea behind vanishing gradient and exploding gradient. So that's all for the lecture part. Now we will be implementing RNNs in TensorFlow. But before that, I would like to explain you the training and prediction part in case of stock price prediction. Suppose this is the sequence of data we have. For us, we can see that it has a common difference of 2, but for time being, we are going to think it as a stock price of XYZ company. So how we create data set? We can take a subset of this data with a definite size. So in this case, we are taking sequence of length 4, and the next number would be the prediction. Here we can see that our X train consists of 10, 12, 14, 16 taken from the given data set. And the next number in the data will be the prediction. So in this case, 18 is our Y train. Similarly, for the next data point, we remove the first number and add the next number. So 12, 14, 16 and 18 will be the next data point and the prediction is going to be 20. We do this across the data and train the model. So this way we force the network to learn hidden pattern in the data. Once we train the network, it's time for us to make the prediction in future. We feed the last 4 data points to the model and we have the prediction 44. And to highlight the prediction, I have used the green color. So for the next prediction, we remove the first element, in this case 36, and add another element that is 44. And this is something we can repeat whatever number of times we want. Again, the idea is very similar to what we learned in the previous slide. So that's all for the theory part. Let's jump to the Google Colab. Before proceeding, I would like to make few things clear. RNNs are actually used in NLP. Predicting stock price is just an application of it. So don't expect your model will be out of the box and it will be able to predict the stock price correctly. We will be learning the actual applications of RNN in NLP lecture series, like building character level models or building chatbots from scratch. For coding part, I am going to prepare the notebook beforehand and I will be explaining you what we are doing in particular code block. So this way we will be more efficient. We are going to use MRF stock price dataset. So where do we get the dataset? For that, we just have to Google MRF share price historical data and click on just second link that has Yahoo in it. So here we have the MRF stock price data. Before downloading the data, we need to configure it. That is how much data we want and whether we want monthly data or weekly data. So first click on time period and click on the max. So this will give us maximum data this site has for MRF stock price. Next click on frequency and click on monthly because we are going to predict month-wise stock price. Next click on apply and this will apply the changes. Next click on download and this will start the download. Next you have to create a folder with the name data in your Google Drive and move that file into that folder because we are going to connect our Google Drive to Google Colab in order to access the data. The next question is how to connect Google Drive with Google Colab. So click on the folder icon on your left hand side, then click on this icon and your Google Drive will be mounted. And once it is mounted, you will have the folder named Drive. Click on that, then click on My Drive, then you will have all the folders that your drive contains. I have a separate folder name with data and in that I have placed my file. So click on data. So here is MRF stock price data. Next click on three vertical dots and copy the file path because we will need that to read the file. So that's all we have to do for data gathering part. These are the libraries we will be required for this project and you can copy paste them from my notebook on GitHub and the link is in the description box. Next we read the dataset using read CSV method of pandas data frame. For that we need file path which we have already copied. Next we set parse data equals to true. This way it will convert the column containing date into datetime object, else it will be object data type. Next we set index column to date. So this will have date as an indices. So let me show you what I'm talking about. So here you see that instead of 0, 1, 2, 3, we have date as indexes. So as an exercise, you can try to run this cell without index underscore column parameter and see the difference between two outputs. Let's talk about the data. So here we have 6 different columns. The first column is open. That is telling us the opening price of the stock for that particular month. So suppose today is the first day of the month and as soon as the market opens up at 9:30, what is the first price of the stock is known as opening price. The next column is high, that is nothing, just highest price of the stock price in that month. Similarly, low is the lowest price it touched during that month. Next we have close, that is price at the last day of the month before closing the market. So suppose today is the last day of the month and market closes at 3:30 p.m. So what was the price at that time is known as closing price. Next we have adjusted close. It is the closing price after adjusting for all applicable splits and dividend distribution. So this is more of a technical term and no use for this lecture. And finally we have volume. So volume are the physical number of shares traded of that stock for a given period of time. So in 7 months it was 20,240 and in the next month it was 25,883 and so on and so forth. Next, using the info method, we get all the information regarding the data. This also helps us to identify which column has missing values. Here we can see that the data has 222 rows and 6 columns, and all these values are floating point decimal. And each column has 222 entries. Had it been the case that one of the columns has less than 222 values, it would have indicated that column has missing values. Next, to verify our claim, we are going to check how many values are missing in each column. For that, we have to call data.isNull method, and it returns binary values for each cell, where false means no missing values and true means there is a missing values. And if we use another method sum, it returns the number of missing value in each column. So let me show you that. And here you can see that it returns 0 for each column. That indicates that there are no missing values in the data. Next, we are going to use only closing price for training the model. Although you can use all the features or columns for this, and this is something you should try yourself. So we create a new data frame which only has closing price data. Next, we plot the closing price. So here we have a graphical representation of it. Here we can see that how the closing price change over the period of time. Next, I would like to talk about decomposition in time series. So what is decomposition? It is defined as breaking the time series data into its component, for example, trends, seasonality, cyclicity, etc. etc. And this is a topic in itself, and I can't go into depth in this video, but I will give you a brief intro to the components of time series. So I have already imported the seasonal decomposition from TSA, that is time series analysis module. Now we just have to call seasonal underscore composition and pass the data and frequency. So here frequency is the property of your data. So if you have collected your data month by month, then it has a monthly frequency. In that case, we have to pass 30. Then we save the result into result variable. So first I would like to talk about seasonality. It is the presence of variation that occur at specific regular interval less than a year, such as weekly, monthly, or quarterly. Seasonality may be caused by various factors such as weather, location, or holiday. For example, if we talk about the sales of mangoes in summer, it will be high due to the fact that they are summer fruit. And after that, we don't see any demand. So this is an example of seasonal variation or seasonality. So in order to get the seasonality plot, we just have to call the result.seasonal.plot and it will plot the seasonality for this data. Next, I would like to talk about the trend. The trend shows the general tendency of data to increase or decrease during a long period of time. So it can be linear or non-linear. So to plot the trend, we call result.trend.plot. So here we can see that our data has upward trend because over the period of time, stock price has increased significantly. And we will be talking about the time series in depth in a different lecture series. For the time being, this information is more than enough for us. Next, we are going to split the data into train and test. So we save the length in a variable named test size. So I'm going to give 36 months, that is 3 years of data for testing. But you can try whatever amount of data you want. Although most people prefer 70-30 or 80-20 split for the training and testing. Next, using ilog, I have split the data into train and test. And always make sure to split the data before applying any sorts of operations to improve the model. Next, we have to scale the dataset because we know that network learn faster on scale dataset. So we are going to use min-max scaler that scales the dataset between 0 and 1. So it is a two-step process. First, we fit the scalar on the training data. Then we transform the data, that is training and test set, using the scalar trained on training data. But now we can do that in one step by calling fit transform method. And for the test set, we are just going to transform the data. Next, we are going to create a time series generator. Why do we need time series generator? So our time series data is univariate and we need to convert into a format that our deep learning model can understand, namely X and Y. So we have to create Y values and the time series generator help us in creating that. And this is something we talked about in the PPT. So first we have instantiated the time series generator. Next we have to pass few parameters. So first we have to pass the X values, that is our scale training set. Then we have to pass Y values. In this case, we need to pass the same data set. Next, we have to define the length. So this length is nothing, just X values we want to consider. For example, in slide, we took 4 values. Here I have taken 15 values, that is 15 month of data. And 60th month will be the Y value. Next, we have to pass the batch size. Here I am passing 1. You can try different values and see how model performs for different batch sizes. Similarly, we create the validation generator and in that we pass the test set and everything else remains the same. And finally, we create the model. So first we have to define what kind of model we want. And so far we have been using the sequential model. And in this case too, we are going to use that. Next, we add the simple Rnns. Then we have to define the number of units. So in this case, I am going to pass 256. You can try different configuration, try to run it with 512 units. Next, we have to pass the input size, which is length by 1 or 15 by 1. Note that I am not passing any activation function because the by default activation function is 10h. Another thing you can try is try to run with ReLU activation function and compare the result of these two different models. And finally, we add output layer that is simply a dense layer with one neuron. Next, we compile the model and we are going to use traditional Adam optimizer, but this time our loss is going to be different. So far, we have been dealing with classification problem where the Y labels were categorical. But now we have continuous variables, so we are going to use MSE that stand for mean squared error. Next, we print the summary of the model. And here we have to train 66,305 parameters, which is nothing compared to the previous project where we had to train 20 crore something parameters. Next, we define the parameters for early stopping in order to avoid any overfitting. So we are going to monitor on validation loss like we have done in previous projects. Next, we set the patience level to 10. So it is going to wait for 10 epochs before stopping the training. And finally, we are going to train the model. So for that, we are going to call model.fit generator because we are fitting the generator and pass the training generator. Next, we have to pass the number of epochs that is going to be 30. And for the validation data, we are going to pass validation generator. Then we pass early stopping in callbacks. So the training has started. So let me fast forward in time. So our model stopped the training after 20 epochs. So let's visualize the training of the model. Here we can see that initially model was doing good, but after some epochs we see an increase in validation loss. And there are ups and downs after that in the validation loss. So next thing you should try different configuration of the model and try to see which yields best result for you. Next we are going to use the model to predict and compare the result with test set. And we have already talked about it that how to make prediction in the PPT part. Here we are just going to code that. So first we create an empty list to store the prediction. Then we create a variable by the name of first batch. And in that we are going to store last 15 values of the training data set. And for that we just have to do the indexing. So the minus sign can be used to grab the last values from the data set. In this case, we are going to grab last 15 values since the length variable has a value of 15. Next, using the reshape method, we convert the first batch into the format that model can understand and save it into the current batch. Next, we are going to run a for loop to make the prediction. Since our test data set length is 36, it's going to run for 36 times. So in the end, we will have 36 predictions. Next, we are going to make current prediction. So it will take the last 15 values from the training data and make the prediction. And in the next step, we are appending that prediction into our empty list. And in the final step, we have to change the current batch data. Remember from PPT after our first prediction, in order to get next prediction, we had to make few changes, like taking one data point out and then adding the prediction in order to create a length of 15 data points. So again, if it seems confusing, go back and watch that part again. So this np.append function takes two data. First, which one we want to remove. So here I have done little bit of indexing. And second, which one we want to add. So here we are adding our current prediction. And then we have to pass axis equals to 1 since we are doing it column wise. So this process will repeat itself 36 times and in the end we will have 36 predictions. Next we have to change the scale dataset into its original form so that we can compare the results. And to do that we just have to call inverse transformation function of our scalar. Then we save it by creating a new column in our test dataset. So let me show you. So here is our actual closing price and next to it is our prediction made by the model. Next we are going to visualize them to see how model is doing. And for that we just have to call plot method and then we define the dimension for the plot. And you can see that the results are not good. So we cannot rely on our model. So try to play around with the hyperparameter and see if you can improve the results. So that's all for this video. If you are new to my YouTube channel, please do like and subscribe and press the bell icon for the future updates. So see you in the next video. Till then, bye, wear mask and stay safe.